Hello everyone, welcome to this lecture. In this lecture, we'll take a deep dive in Amazon EMR. We'll start by looking into the different blocks in a data solution. We'll start with moving data to AWS, then the data collection and data aggregation, and finally onto data processing. And we'll also look into cost and performance optimization considerations. A number of approaches are available for moving large amounts of data from your current storage to Amazon S3, or from Amazon S3 to Amazon EMR and the Hadoop distributed file system. Scenario 1: Moving large amounts of data from HDFS to Amazon S3. S3 Disk CP and Disk CP can help you move data stored on your local data center SDFS storage to Amazon S3. S3 Disk CP is an extension of Disk CP with optimizations to work with AWS, particularly Amazon S3. By adding S3 Disk CP as a step in a job flow, you can efficiently copy large amounts of data from Amazon S3 into SDFS, where subsequent steps in your EMR clusters can process it. You can also use S3 Disk CP to copy data between Amazon S3 buckets or from HDFS to Amazon S3. The main optimization that S3 provides over Disk CP is by having a reducer run multiple HTTP upload threads to upload the files in parallel. Disk CP, that is distributed copy, is a tool used for large inter or intra-cluster copying of data. It uses Amazon EMR to effect its distribution, error handling and recovery as well as reporting. Disk CP can copy data from HDFS to Amazon S3 in a distributed manner similar to S3 Disk CP. However, Disk CP is not as fast. Scenario 2: Moving large amounts of data from local disk non-HDFS to Amazon S3. Jet S3T is an open source Java toolkit for developers to create powerful yet simple applications to interact with Amazon S3 or Amazon CloudFront. It provides low-level APIs but also comes with tools that let you work with Amazon S3 or Amazon CloudFront without writing Java applications. GNU Parallel is a shell tool that lets you use one or more computers to execute jobs in parallel. GNU Parallel runs job, which can be a single command or a small script to run for each of the lines in the input. Using GNU Parallel, you can parallelize the process of uploading multiple files by opening multiple threads simultaneously. In general, you should open as many parallel upload threads as possible to use most of the available bandwidth. Aspera has developed a proprietary file transfer protocol based on UDP, which provides a high-speed file transfer experience over the internet. One of the products offered by Aspera, called Direct to S3, offers UDP-based file transfer protocol that would transfer large amounts of data with fast speed delivery to Amazon S3. AWS Import-Export accelerates moving large amounts of data into and out of AWS using portable storage devices for transport. For significant datasets, AWS Import-Export is often faster than using an internet-based data transfer and can be more cost-effective than upgrading your connectivity. AWS Direct Connect makes it easy to establish a dedicated network connection from your premises to AWS. Scenario 3: Moving large amounts of data from Amazon S3 to SDFS using S3 Disk CP. As we saw earlier, S3 Disk CP lets you copy large amounts of data from your data center SDFS storage to Amazon S3. You can also use the same tool and a similar process to move data from Amazon S3 to local SDFS. You can also use Disk CP to move data from Amazon S3 to SDFS. Since S3 Disk CP is optimized to move data from and to Amazon S3, AWS recommends using S3 Disk CP to improve your data transfer throughput. Data collection. One of the common challenges of processing large amounts of data in Hadoop is moving data from the origin to the final collection point. In the context of the cloud, where applications and compute resources generate massive amounts of data in a short period of time, collecting data in a scalable and reliable manner has an important place in big data architecture. Apache Flume is a distributed, reliable, and available service for efficiently collecting, aggregating, and moving large amounts of log data. The architecture of Flume D is very similar to Apache Flume or Facebook Scribe. Flume D is easier to install and maintain and has better documentation and support than Flume and Scribe. Data aggregation refers to techniques for gathering individual data records, for example log records, and combining them into a large bundle of data files, For example, in web server log aggregation, a single log file records all recent events. Aggregating data records on Amazon EMR has multiple benefits. Improves data ingest scalability by reducing the number of times needed to upload data to AWS. In other words, instead of uploading many small files, you upload a smaller number of larger files. Reduces the number of files stored on Amazon S3, which inherently helps provide better performance when processing data on Amazon EMR. Hadoop, on which Amazon EMR runs, generally performs better with fewer large files compared to many small files. Provides a better compression ratio. Compressing large, highly compressible files is often more effective than compressing a larger number of smaller files. Like distributed log collection, you can configure log collectors like Flume and Fluentd to aggregate data before copying it to the final destination. Below are some of the data aggregation best practices. The suitable aggregated data size depends on the compression algorithm you are using. For instance, if your log files are compressed with gzip, it is often best to keep your aggregated data file size to 1 to 2 GB. The reason is that since gzip files cannot be split, Hadoop assigns a single mapper to process your data. On the other hand, if your data files can be split, more than a single mapper can process your file. The suitable size for such data files is between 2 GB and 4 GB. If you are using a distributed log collector, you are limited to data aggregation based on time. For example, you can configure Flume to aggregate data for 5 minutes before sending the aggregated files to Amazon S3. We recommend you perform your own testing with different time values in your aggregation configuration to understand which value gives you the best file size aggregation. Overall, since most distributed log collector frameworks are open source, you might be able to write special plugins for your chosen log collector to introduce the ability to aggregate based on file size. Depending on how large your aggregated data files are, the compression algorithm becomes an important choice. Compressing data is important for several reasons. Lowers storage cost by reducing your data storage footprint. Lowers bandwidth costs by moving less data from the source to the destination. Better data processing performance by moving less data between data storage location, mappers and reducers. Better data processing performance by compressing the data that Amazon EMR writes to disk, that is, achieving better performance by writing to disk less frequently. Naturally, not all compression algorithms are alike. As the table below suggests, some compression algorithms are faster. You need to understand your workload in order to decide if faster compressions are any use for you. For example, if your job is CPU bounded, faster compression algorithms may not give you enough performance improvement. If you decide compression speed is important, snappy compression seems to perform faster. Some compression algorithms are slower but offer better space savings, which may be important to you. However, if storage cost is not an important factor, you may want a faster algorithm instead. Importantly, some algorithms allow file output to be split. The ability to split your data file affects how you store the data files. If the compression algorithm does not support splitting, you may have to maintain smaller file sizes. However, if your compression files can be chunked, you may want to store large files for Amazon EMR processing. Compressing the input file is not the only place in Amazon EMR data processing where compression can help. Compressing the intermediate outputs from your mapper can also optimize your data processing workflows. Data partitioning is an important optimization to your data processing workflow. Without any data partitioning in place, your data processing job needs to read or scan all available datasets and apply additional filters in order to skip unnecessary data. Data partitioning lets you create unique buckets of data and eliminate the need for data processing job to read the entire dataset. Although Amazon EMR makes data processing extremely easy and convenient, your data processing workflow can still benefit from several considerations. Picking the right instance size and the right number of instances for your job, and estimating the number of mappers your job requires. Amazon EMR has two cluster types, transient and persistent. Each can be useful depending on your task and system configuration. Transient clusters are the clusters that shut down when the job or the steps, that is, a series of jobs, are complete. Persistent cluster, as the name implies, continue to run after the data processing job is complete. Cost and performance optimizations. AWS provides a variety of ways to optimize your computing costs. Depending on your Amazon EMR workload, you can optimize your costs for Amazon EMR by purchasing EC2 reserved instances or spot instances. On demand instances are a good option if you have transient Amazon EMR jobs or if your Amazon EMR hourly usage is less than 17% of the time. However, if your Amazon EMR hourly usage is more than 17%, reserved instances can save you money. Monitor your Hadoop mapper tasks and note how long they run on average. If they have a short lifespan, for example seconds rather than minutes, you may want to reduce the number of mappers. If your map tasks are short lived, it is likely that you are processing small files and you can benefit by aggregating them into large files. Your job should use fewer reducers than the cluster's total reducer capacity. Reducers should finish at the same time and not allow reducers to wait for execution, which happens if your job uses more reducers than the cluster's capacity. Use Ganglia for performance optimizations. The Hadoop Job Tracker Web UI gives you easy access to Hadoop's internal metrics, which can be used for tuning Hadoop jobs. For additional reading on this topic, please use below links. So in this lecture, we took a deep dive in Amazon EMR. In the next lecture, we'll look into EMR node types. All the best and have a nice day. Thank you.